For part 2 of this lesson, a landowner wishes to use 2,000 feet of fencing to enclose a rectangular region. What should the lengths of the sides be in order to maximize this area? What is this 2,000 standing for? How much fence is needed? What can I call that? If that's my fence, this is my perimeter. Now, I don't know these sides, what they are. So I'm just going to call one of them X and the other one Y. You can call it Lucy if you want to. What do I know about perimeter? Well, it's 2x plus 2y. We're not using L and W's. What do we know in this problem? It's 2,000. We need to solve for one of the variables. Solve for y. First thing, subtract the 2x, and then divide everything by 2. So what's 2,000 divided by 2? 1,000 minus x is what y is. What are we trying to find in this problem? What are we trying to do? Maximize the area. So how do I find area of that shape? Length times width. So in this problem, it would be x, y. So area is x, y. We want to maximize. Now, if we're talking about maximize, what's another thing we can think of it as? We can think of it as an extreme value. How do I find extreme values? All right, the first thing I'm going to do is I'm going to substitute in. So I have A equals x times 1,000 minus x, which means 1,000x minus x squared. If I put it in now, it saves a lot of problems later. To find an extreme value, I'm going to take the derivative. So the derivative, 1,000 minus 2x. That's my derivative. Now, how do I find the extreme value? I just took, because y means 1,000 minus x, then I distributed, then I took the derivative. To find an extreme value, this has to be 0. And now I solve. Add 2 over, so 2x is 1,000, x is 500. So this tells me I have an extreme value at 500. There's also 2 more. 0. It could be 1. There is another one. What's that? 1,000? Where'd you get 1,000 from? Right here? It's not it. could be 2,000. But does the 2,000 make sense? Why not? I could use no fencing. So this could be a 0, or it could be the maximum of 2,000. This one doesn't make sense. Right, it would be, actually, yeah, it'd just be a straight line because all the fencing is on that side. Also, if this side was 0, there's no fencing on the sides. So that one doesn't make sense even. So solve for the 500. Put 500 in and solve. Now there's all these formulas. Which one do I put it into? Am I going to put in perimeter, the area, or the derivative? Not the perimeter. Not the derivative. We got one left. Area. Why the area? We're trying to maximize the area. That's the main thing we're looking at.
Well, I was looking at, we'll put that 500 to that X and Y, 1,000, 2,000.
I mean right here? Right here. But we're not trying to maximize the perimeter. We already know the perimeter is 2,000. So I'm going to put in 500 here. So I have A of 500 is 1,000 times 500 minus 500 squared. Put in the calculator. The answer is 250,000. What are we talking about here? Meters, feet. That is the maximum area I could have. Now, just to show you, if I would have put in my 0, that's a 0 here, that's a 0 here, the maximum area is 0. If I would have put in 2,000, I'm going to get 0 again. Do you understand how we maximize the function? Okay, write this one down. A company is creating shipping boxes. The company wishes the volume of each box to be 6 cubic feet. The box's base to be a square with a side between 1 and 2 feet. The material to make the bottom costs $5, the sides $2, and the top $1 per square foot. Find the dimensions that would yield the minimum cost. In this problem, we're talking about the volume of the box. So the box has to hold 6 cubic feet. But when I'm talking about the material to make it, what are we talking about there? It's not, you don't have perimeter of a 3-dimensional shape. This would be the volumes, how much goes in the box. We want to know how much it is, not just area, it's going to be surface area. All right. So we're talking about volume. Volume, the formula for a cube, because it says the box's base is a square. So I'm going to have x cubed. First thing we need to do is solve for x. No, the marker just tailed off. What do I know about the volume? Volume has to be 6. So 6 equals x cubed. So what's x? cube root of 6. So x is the cube root of 6. Surface area, the formula. Now, surface area, this wasn't on your test or quiz. All right, the 2LW plus 2LH plus 2WH. Those are the three. But what do I know about all of this here? That's 2LW. What are we talking about in this problem? It's a cube. So these are all the same. So that's an x, 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 that's an x. So another way to think of it as, how many 2's did I have there? 3. So I have 6x squared. If you think I had 2LW, 2LH, 2WH, what's L, really? X, what's W? What's x times x? X squared. So I'm going to put in and find the derivative. So the derivative of the surface area is 12x. How do I find an extreme value? Make that 0. Divide by 12, x is 0. What happened? Ran out. So what does that tell me? I have a critical value at 0. Okay, now thinking about it, can I have a side of 0? No. So does that answer even make sense? No, it's a critical value or an extreme value, but it's not one we're going to use. Are there any other extreme values in this problem? Bless you. Extreme values. Between 1 and 2 feet. So I have an extreme value at 1, an extreme value at 2. So I'm going to put in SA of 1, SA of 2. 6(1) squared, 6(2) squared. This one's 6, this one's 24. Which one's going to give me a minimum value? 6. So my minimum value is, each side should be 1 foot. That's your answer. The dimensions would be 1 by 1 by 1. Each side needs to be 1 foot. What didn't I need in this problem? What didn't I need? The money. The money means nothing for this answer. Now, if I would ask you, how much does it take to create that box? Then I could go, we know it's 1 for each side, right? So how many square feet do I need to make the bottom? 1, because it's 1 times 1, right? Actually, we'll just do cost. How many sides does the box have? How many sides? We're not talking about top and bottom. 4. So it's 1 times 5 plus we have 4 sides times 2 plus, and the top is, there's only one top times $1 to make the top. So I have 5 plus 8 plus 1. $14 to make the box. A very expensive box. Well, we're not making out of cardboard. This could be made out of something else. I mean, the fact that the bottom costs $5, the sides are 2, and the top is 1. It's not just a folded piece of cardboard. It's using different things. I doubt it for $14 you're going to get something made out of gold. Questions on this? Okay.